Okay, welcome everybody. We're excited to kick the DSS monthly with one of the most interesting topics in the field of DeFi. Before I introduce the moderator, let me update you on the DSS, on the main event, which is coming in Bangkok in November. So thank you all the 180 submissions. We assembled actually a very nice core review committee. We will try to give you answers as soon as possible. We want, of course, to, like last year, to accept as many workers as possible, but we also understand that last year there were a lot of complaints that the schedule was too packed. We will try to do the best job in assembling the program. So for today's webinar, I'm very excited and honored to welcome Mehdi. Mehdi is actually leading one of the strongest security company in this space, SigmaPrime. He's actually contributed security in all levels, starting from the consensus, going to the smart contract. And I think he's the perfect person to lead this webinar. Excited to pass it to you, Mehdi.
Thank you, Muli. Thanks for the kind words. Hey, everyone. My name is Mehdi, co-founder and director of SigmaPrime. We're a blockchain security and research firm doing a lot of security work, obviously, in the Web3 space, but we're also the founders and maintainers of Lighthouse, the Ethereum consensus client, free, open source, written in Rust, and responsible for about 30% of the Ethereum blocks produced on mainnet today. I'm very excited to be here. This is a topic that has kept SigmaPrime quite busy over the past few months, restaking security. I'm joined today by two amazing speakers, Anto from Eigen Labs and Algys from Symbiotic. We'll cover a whole bunch of different topics. There's time for questions, so please feel free to submit your questions in the chat. We'll select the most relevant ones and we'll ask them to our panelists. Anto, do you want to introduce yourself?
Yeah. So I'm Anto. I'm with Eigen Labs. I've been with EigenLayer for almost a year now, and I help with all things security. So that's me.
Awesome. Thank you. And Algys, do you want to do the same?
Yeah, I'm Algys. I'm co-founder in Symbiotic. I have experience in protocol development, DeFi development, and security as well. So I'm in Symbiotic from the start. Yeah.
Awesome. Thank you. So for those of you who have been living in a cave, restaking has kind of taken DeFi by storm. It's currently responsible for about $10 billion, just over $10 billion of staked value. And they've gained a lot of traction in the DeFi space over the past few months. So I'll pass it on to Anto to give us an overview of what restaking is and perhaps some of the particularities that EigenLayer has used to approach this new topic. Over to you, Anto.
Awesome. Can you guys see my screen?
Yep.
Amazing. Okay, let's get started. So as I said, I'm Anto. I've been with Eigen Labs for the past 1 year. I've been doing security for the better part of my career. Previously, I was with Base, and now I'm doing a bit of protocol security and a bit of Web2 security at Eigen Labs. So we'll walk through what is restaking, what is EigenLayer, what is programmable trust, and then we'll get into how our smart contracts work. And then we'll look at what are the features that we launched in the past 6 months, and then what are our security practices. So that's how I'm structuring this talk. Okay, so what is EigenLayer? So EigenLayer is a protocol built on Ethereum that introduces restaking. And it's a new primitive in crypto economic security. So we'll dive into what that is. So essentially what that means is users can restake and extend trust beyond Ethereum, and you will be rewarded for doing so. So let's understand what is restaking. This is a screen cap from our website. It says restaking enables staked ETH to be used as crypto economic security for protocols other than Ethereum in exchange for protocol fees. So that is how we started. But recently, we launched permissionless token support. Now you can restake not just ETH, but any arbitrary ERC20 tokens permissionlessly on EigenLayer. And we also have an update to EigenPods, which is our native staking mechanism on EigenLayer, and I'll explain what that is. But what I want to allude to is that it now supports beacon chain rewards as well. So it is going beyond just ETH on the beacon chain. Now you can have the beacon chain rewards like MEV boost rewards or something like that. And why do we need restaking, right? Like one of the biggest problems in crypto is bootstrapping decentralized infrastructure, and restaking is really, really good. And we'd fix this problem of bootstrapping in decentralized infrastructure with programmable trust. So what is programmable trust? So we can think of programmable trust as these three pillars. There is economic trust, that is amount at stake. That is how Ethereum works today. You put up 32 ETH and you become part of the Ethereum 2.0, right? And decentralized trust alludes to the geographic diversity of the nodes that participate in the network. And then there is the Ethereum trust, like the Ethereum validators who validate Ethereum also opt into validating your network. Or you can design mechanisms like proposer commitments, which is considered as the Ethereum trust pillar. So to understand what is restaking, we need to understand what is staking. And the very basic version of staking that I think we should be familiar with is Ethereum staking. So what happens with Ethereum staking, right? Like stakers put up 32 ETH, it goes to a pending state, and when the chain is ready, your validator becomes active and it starts validating Ethereum tasks. So these are rules set by Ethereum, the protocol, that the validator has to do. And if it does its job correctly, it gets rewards. And if it doesn't, it gets slashed. So this is how Ethereum works today. And these rules are transparent, it's written, it's part of the core protocol. So you just follow the rules, and if you don't do anything malicious, you are very unlikely to get slashed. And when you want to withdraw your collateral, you can just exit. Now, restaking looks very similar. So stakers have already put up 32 ETH to secure the beacon chain, right? So you can commit this capital to validate external networks or tasks and get rewarded for that work. And you are also subjected to slashing like in Ethereum. So you already have this capital that is committed on the beacon chain. So now you can use that to validate other tasks as well with restaking. So you don't need to like come up with new capital. So this is capital efficient in a way, right? And you can choose to like validate a bridge, be an oracle, be a DA layer, or like an entire L2 if you want to. Now, recommitting this capital into doing this arbitrary tasks could be considered restaking. At least that is my definition of restaking. Now, why can't we just put up more money and make this happen, right? Like, why do we need to like reuse capital? If you look at this, you have the efficiency you get by pooling capital. It's just so good. And when you distribute capital, you lose out on shared security because there is a single pot that is securing one task. And what is AVS, right? AVS is a term that we coined. It's called actively validated services. So this can be like a bridge that is restaked. This could be like a roll-up. So any arbitrary tasks or services on a restaked network could be called an AVS. So if we were to allocate capital separately to these AVSs, that is not very capital efficient. So restaking with EigenLayer allows you to secure more AVSs without splitting up the capital, and that improves the security guarantees of the AVSs itself. And these are some examples of what you can build with restaking. There is a blog post on blog.eigenlayer.xyz where you can read all about all the various things that people are building. This is just a small subset that could fit into this diagram. And let's go a little in depth, right? We've been talking a little high level about restaking, but what does it look like? So stakers commit their capital. So we support any ERC20s right now. So you could be using USDC. You could be using wrapped. You could also be using LSTs like STETH. You could also be using native ETH because we support that too. We have native restaking, right? So you commit this capital into the smart contract. We can call it the token manager here. And then you can delegate the capital that you have with us to an operator. An operator could be someone like Coinbase Cloud or a home staker, right? All of them can register with EigenLayer and will be listed in our UI and in our smart contracts. So you can choose to delegate your capital to an operator. And the operators would run these AVSs. And these AVSs can be bridges, it can be a DA layer, it could be an Oracle. So these services are run by operators, and now stakers are backing the services that are run by the operator. And now you have slashing, right? So when an operator does their job correctly, all is good, you get rewards, and that's it. But if an operator were to act malicious, the slashing contract of that AVS is responsible for penalizing that operator and taking away funds from that operator. So this is more of a deterrence, like as in Ethereum, right? Like there is not a lot of slashing that is going on. It is because if you act malicious, you can lose your collateral. So like in the same way, operators tend to not act malicious because there is a penalty or slashing. That is really what it is. And if you are interested in a bigger deep dive of our architecture, I would really recommend the GitHub link below, which has detailed diagrams and documentation on how our contracts work. And I'll have a QR code at the end of the presentation, which you can just scan and like go to our repositories and like get started. And now I want to talk about the various risks and mitigations. All of us are like security professionals here, so we worry a lot about risk and how do we mitigate them, right? Like, so this is the juicy part. Now, the biggest risk that we worry about are the smart contract risk. Like every day we wake up to like a new smart contract hack. In fact, even today there was one. So what are we doing to like minimize the risk of smart contract hacks? So we have a withdrawal delay. So there is a 7-day delay before any capital exits EigenLayer. And I will go into detail about what that is. We have active monitoring. So all our on-chain activities are monitored 24/7, and we have redundant systems doing the monitoring in case one of them goes down. We have protocol governance, much like most DeFi protocols. There is a multi-sig with many parties in it, and I can go deep into that. We do get security reviews from the best folks in the industry. I have a list, so we'll see that later. And we internally have a good product security team, and we hire the best folks we can. So if you are interested, please hit me up after this presentation. We are still hiring. And we also have the best-in-class bug bounty. I believe we have $2 million a bug bounty on Immunify if you have a critical bug on EigenLayer. So let's talk about withdrawal delay, right? So this is a EigenLayer contracts feature where there is a 7-day withdrawal delay. And we can use this to mitigate any critical security issues that we come across, or if there was a vulnerability disclosure and we need to mitigate that. We can also pause the contracts and do upgrades if need be. And the caveat to the system is that there shouldn't be an issue with this logic, right? Like the potential for a vulnerability that can bypass the withdrawal delay is really high. So we want to make sure that doesn't exist, and we do a lot of work to ensure that's the case. The second is the risk of a flaw in the code that is managing the request after they have undergone the delay period. So a withdrawal delay doesn't fix it all. We understand that, but we try really hard to make sure there are no exceptions. And as I said about monitoring, we have invariant monitoring, which is awesome. I recommend everyone do that. So when you have protocol invariants, you have to enforce it every block. So we do that every block on mainnet. We have this invariant setup with Hexagate, and then we run it per block. So even if it is not a malicious transaction, but somehow triggers an invariant, we know we have done something wrong, and we can go fix that. And we have an on-call system where if something were to happen on chain, we can immediately show up and pause the contracts if need be. And we also think about tabletop exercises a lot. So we are actually ready to act in case of a real emergency. We also have a multi-sig based protocol governance, and we have the operational multi-sig, a pauser, and a community multi-sig. And all of this information is available on our docs. So I totally recommend reading that. And this is just a visual way of representing what these multi-sigs are capable of. These are actually detailed in our docs. So if you are interested, I really recommend just visiting docs.eigenlayer.xyz. We also have the best. We get the reviews from the best in the industry. Here is a list of all the audits that we have done recently, and here is a link to all the audits in our public GitHub repository. We also have economic risk, right? Like, so restaking is not just about slashing risk. It's also about economic risk. We have an awesome slashing design that I'm so excited about. I've been asked not to spill a lot, but I really want to say that this is something brand new, and we have been working with our partners and industry leaders and researchers to come up with this design. We iterated over many designs and arrived at this new design, which has way better trust assumptions. And I'm so excited to tell you that it will be launching very soon. Like, you can tweet at me if that didn't happen. I'm so confident it's happening in maybe in a matter of weeks, you know. So I'm super excited to like put the design out there so for community feedback. And we also have talked about StakeSure, which is the insurance protocol that Sriram has written a paper about. So if you are interested in that, it's also a roadmap item that could help with slashing risk. And LRTs are a big portion of our economic sponge maybe, because LRTs help us not financialize. If you deposit funds directly with EigenLayer, you are not getting a liquid token, right? But people would like the efficiencies of a liquid token because they could do DeFi with it. So having LRTs help us not financialize directly, and that has huge advantages. And we have put out a lot of educational content on blog.eigenlayer.xyz about economic risk. This is a evolving discussion, and now that we'll have slashing soon, there is going to be a lot more material, and we'll be sharing those on our Twitter and our blogs. So this is what I was really talking about when I was talking about LRTs. It really helps us not financialize, and it helps us with down markets, especially if there is some sort of like a liquidation. The beacon chain is not really affected because you can deal with it at the lending protocol level, where you just liquidate the collateral. If you were to do it with LRTs, instead, if EigenLayer chose to do it directly, it may have a huge impact on the beacon chain, right? Because there might be a lot of withdrawals that the beacon chain may have to process because people have to repay their loans and all that. So that was a very good thing. Yeah, so LRTs really do help us. And we also have AVSs, which is the software that all the operators run. And there is a lot of risk around that. So here I'm talking more about the economic risk. There is also the cybersecurity risk of like running regular software with exploits and all that. But I'll focus on the slashing risk, and we think a lot about anti-slashing, like slashing DB. If you are a Ethereum staker, you would know what a slashing DB is. So something like don't sign the same block twice, which is a very basic rule that you have to follow, and that can be enforced by a slashing DB. Now imagine something like that for AVSs, right? So this can also apply to AVSs. So that is something that we are thinking about. And then we take a lot of inspiration from distributed validator technology, which is also really helpful for as Ethereum stakers. These can also be used for AVSs, right? And we have put out a developer best practices guide, which talks about a lot of these Web2 risks. So you can, as an AVS developer, you can really like use that guide when you develop your software. Okay, so what did we launch recently? AVSs went live on mainnet. So if you go to app.eigenlayer.xyz, you can see a bunch of AVSs that you can use today. So that is exciting. And we also launched the foundation, the Eigen Foundation, who did the Eigen stake drop. So that is also very awesome. And we launched permissionless token support. So we are no longer tied to just Ethereum and LSDs. We also further extend the economic security that we can provide to AVSs with any arbitrary ERC20s. So that is awesome. And it's up to the AVSs to like determine if that is an asset that they are interested in. So the AVSs can choose to accept USDC if they wanted to, right? So that is possible now. And the EigenPod upgrade that I talked about earlier, that has significantly reduced the gas cost in claiming your rewards on EigenLayer. Earlier, our proof system was a little expensive, but with the checkpoint system that we have, so you can have multiple validators create one single proof, and you can that translates to huge gas savings. So if you are interested, hit me up. I can send you a link. We have also tweeted about it, so you can find that link there to read more about the Pepe upgrade. And as I said, slashing, it's coming really, really soon. I'm super excited to talk to you all about it very, very soon. And That's pretty much it. So TLDR, it serves as a platform connecting stakers and infrastructure developers. Stakers can offer economic security. Stakers have the option to restake their stake and contribute to the security of the infrastructure while earning rewards. Through restaking, EigenLayer pools security instead of fragmenting it. So next steps, if you are interested, you can click on these links. I'll share the presentation. So you can click on these links to learn more about how you can build on EigenLayer. You can join a hackathon. You can follow us on Twitter, or you can just scan this QR code and get a link to our GitHub. That's pretty much it. Thank you. Over to you, Mehdi.
Awesome. Awesome. Thank you so much, Anto. This was amazing. Great content, and glad we could share the security side of what you guys have been cooking with the audience. So thank you. Much appreciated. Algys, you're up next. You're going to give us, I believe, a similar introduction to restaking, but through the symbiotic lens. Very excited about that as well. Over to you.
Thank you, Mehdi. Yeah, let me share the screen. Yeah, here we go. Okay, so let me introduce myself again a bit. So I'm Algys, I'm co-founder at Symbiotic. I have kind of wide experience in protocol development from like consensus protocols, networking, databases, also in DeFi. I've built in liquid staking protocols and security. So I spent like 4 or 5 years in auditing, in bug bounties, submitted different bounties and got paid for that. Yeah, what's the Symbiotic? Symbiotic is general purpose shared security protocol. It's not limited by restaking, but it has feature as restaking. Our goal is to make as tiny as possible layer that allows networks to get decentralization. So we are just helping them to bootstrap their decentralized set, their staking protocol. We are building just primitives to simplify this process. The main conception of the protocol is to be permissionless. It's about all aspects. It's about the tokens. It's about the control over the protocol. Network should have full control over their staking infrastructure and not be dependent on third-party decisions or external DAO, whatever. Because the staking is kind of critical part of any network. So it's usually can lead to disaster, basically to if staking is not operational, network itself is not operational, or if there's a bug in staking protocol, stake can be frozen or stolen, or if there's a bug in staking protocol, network can be compromised. That can lead to asset to be stolen from the network or any other bad stuff. So basically, the staking is a central part of any protocol. Consensus depends on staking. Business logic depends on consensus and staking, and also usually token also depends on staking. Yeah. So from network's perspective, the protocol itself very kind of 90% of design decisions was targeted to make networks secure enough. So basically, networks should avoid any extra trust assumptions on staking. So basically, they're staking vertical. I mean, they're staking code, their walls, their whatever what they have on the staking side. It should be completely permissionless. It should be controlled only by network, including the upgrades. So nobody should be able to upgrade their staking protocol, including contracts, whatever. functions like slashing, like rewards, fees, etc., shouldn't be also controlled by anyone. The second stuff is restrictions and whitelists. It's more about the protocol limitations, like tokens, different staking models. So they should have flexibility to control what kind of tokens they want to accept, what kind of staking system they want to build. So, for example, multi-asset staking. They should be able to decide how to reward what portion of stake, where from to receive this stake, how it should be delegated, how it should be managed. Yeah, to solve this kind of permission, to make it permissionless, we had to go through a lot of technical challenges. I just listed several of them here, but there was a lot. So basically, when we want to stay permissionless, that means that we let networks decide over their upgrades, over their new features, etc. While we are as a Symbiotic still building the core protocol. So we are just shipping new features. We can ship new features. We can add new contracts, etc., etc. But we want to limit our role in networks. So we need to choose the right decision how to make the system immutable or upgradable while losing the control from our side and leaving networks to decide. Yeah, basically, the second question is to how to avoid dependencies. Basically, it's about the single point of failure or centralization around some decisions, like slashing, like browsing, whatever. We don't want the networks be correlated with each other. Their security aspects should be isolated. So basically, if one protocol decided to pause or slash, other protocols shouldn't be affected or pause it as well. The third one is so when we try to build a permissionless system with a lot of different contracts, we realized that it's kind of very expensive. And we had to decide and find a way how to keep it cheap while having the flexibility, because flexibility means that we should implement a lot of features. A lot of features means that we have a lot of code that should be shipped to core part. That means that we have like some issues with gas, etc. So the solution was kind of simple from current perspective, but it was hard to find it. In terms of upgrades, we have introduced a new pattern, which is migratable. I will highlight a bit later. In order to keep the flexibility, we introduced modularity. It's kind of very old concept, but it simply allows us to keep internal interfaces and internal API between the models and abstract particular implementations of like slasher, delegator, whatever. It allows us to ship new models in future. It allows to networks, to LRTs, to stakers, to operators to choose what particular model they want to use, what particular implementation of what particular model they want to use. That saves the gas in terms of the size of bytecode, etc., because they're using particular model that doesn't have parasite code that doesn't affect it and related to this particular delegation staking strategy. Yeah, it's about migratable. So basically, we had two concepts, immutable and upgradable. immutable contract is very good, but they have some limitations. It's not really easy to add new features. It's not really it's not really easy to ship new versions. That's not just simple features, but if we want to like introduce new version, it will mostly in most cases it will require some migration of funds, like similarly with Uniswap or like other protocols that they have immutable contracts. Another concept in opposite is upgradable. So basically, if you have upgradable contracts, it's much more easier to upgrade it. We can introduce as many features as we can. It doesn't require migration of funds in most cases, but it depends from some external DAO, for example, Symbiotic DAO, if there exists a feature or some multisig or some committees, because we have single place, single like entity that controls upgrades, basically. We definitely want to avoid that because, as we mentioned before, staking is critical part. So nobody wants to be dependent on external protocol too much. So that's why we came to migratable. It's the combination of immutable and upgradable. Technically, it's more like upgradable, but the upgrade pipeline and upgrade path is strictly the upgrade path is immutable. So basically, we have factory that forbids us to upgrade contracts that was already deployed before. The only thing that we can do from protocol side is to propose new versions. When we propose new versions, owners of previous implementations can decide upgrade to new version or not. So for example, like we ship version 2 and just add it to the factory, and everyone can decide to deploy version 2. If they had already version 1, they can decide to upgrade to version 2. We predefine the upgrade path so they can be ensured that their storage and everything will be migrated perfectly. But they can still stay on the version 1 if they want. And also they still can deploy version 1 even if we have version 2. So they have full choice and full control over which version they want to operate. Yeah. The second aspect that we have in a core protocol is modularity. Basically, in very, very high level, we will have three different types of contracts. The first one that I already mentioned is migratable. The only contract that we have migratable is Vault. The second like logical niche of contract is modules. It's Slasher Delegator currently, and we also have some common immutable contracts like services and registries, for example, network registry, operator registry, opt-in services, etc. That's basically briefly if we say about the vault, is basically the key entry point and connecting entity contract that basically connect each module which is each other. So basically Vault determine which kind of slasher they want to use, which kind of delegator they want to use, and it connect with services and registries in order to verify that okay, network is registered or operator registered or they had opt-ins in order to receive stake. Yeah, a little bit deeper about the models. So basically, currently we have two contracts as a models. The first one is slasher, and the second one is delegator. The reason behind why we introduced models was because we have different kind of slashing systems. We have different kind of delegation systems. And we understand that in the future, it's possible to have more different like models in this regard. So that's why currently we have just only 2 implementations for each model. So for Slasher, we have simple Slasher that basically very simple version of Slasher that only check that, okay, operator was able to be slashed at some point. That was opted in, network was opted in, Vault committed some amount of collateral, and Slasher just executed this request. The second one is Veto Slasher. Veto Slasher is much more complicated. It introduced some vetoing logic. So basically, when slashing request is accepted, Veto Slasher allows to predefine its resolver to veto the slashing request during the predefined amount of time. Yeah, so that's kind of very simple concept that allows to networks and vaults and operators to consensually decide which kind of resolver they want to use. It can be automated resolver, for example, smart contracts that validate proofs or something. It can be committee still. It can be some DAO or I don't know, or some external like third-party entity. About the delegators, we also have 2 versions. The first version, network restake delegator, is kind of default solution that we propose to networks and vaults to use. It allows to restake the assets collateral across different networks, while forbidding it to be restaked within the same network. So just to avoid the risk when your operator, like you have 2 operators within the same network and they have both restaked collateral. So when you slash one operator, the second one gets slashed automatically. Wants to avoid that in most cases. That's why we have like default network restake delegator. The second one, full restake delegator, doesn't have such an invariant. So basically, if you use that delegator, you can easily have restaked operators within the same network, restaked operators, restaked networks across like different networks. The use cases are wide. So we basically you can have insurance system. So basically, you can create fund that have full restaking that covers like different operators. And in case of slashing, you first slash this vault, then just by order you can go to normal vaults. Yeah. Networks. So as I mentioned before, Symbiotic is kind of very tiny layer of between the stakers, between the operators and networks. So that means that networks should be aware of trade-offs and aware of potential security issues. There is no middleware. There is no entity or DAO that controls aspects of their staking. The only entity, the only like participant who should care about the security of the network security and the staking vertical security is the network. So that's why network should run through like comprehensive onboarding process in terms of the vaults that they want to receive as a staking source, or collateral that they want to receive as a collateral. So basically, collateral can have different trust assumptions, especially if it's a bridged asset or some sort of obligation-based asset. For example, it's native staking. It's
as obligation over native staked ETH on the beacon chain, or obligation over staked token in some, like, I don't know, other Cosmos, like Cosmos chain. Additionally, they need to diversify like the stake sources. Our design supports network and incentivized networks to use different source of stake. That means that they can have different vaults with different rules, for example, with different delegators, with different restaking ratio, with different networks, with different operators. So the best practice here is to maintain good diversification across the vaults in order to maintain your like desirable target restaking ratio. So for example, if one vault have 100 network is like restaked networks, and another will have 10 restaked networks. You can choose what amount of restaked networks it's perfect for you, because when you have too much restaked networks, you have more risks that your kind of security can be affected by other networks. So you have full flexibility in choosing like what amount you need, what amount of ratio you need. You even can have your own vault when you forbid networks to be restaked. So basically, Symbiotic, as I mentioned before, is not only restaking, it's like shared security protocol in general. That means that you can build your staking vertical, not restaking, and combine restaking with staking and vice versa. Yep. So the networks are basically the only entity who should care about it. We do have best practices. We're continuously working on improving the security and making networks aware of any aspect of security that they need to care about. But everybody should understand this very like simple stuff. Yeah, and a little bit about Symbiotic security. So basically, we went through a long way from like first version of specification to final code. This is our like the story how we get how we get there now. The first thing that we did, we never start writing the code and trying to implement complicated stuff. Rather than that, we have practice when we simulate code before implementing it in Solidity. So basically, we use Python, we use different techniques, we use different fuzzing techniques to implement like model, not the implementation of contracts, but the model that is supposed to be implemented in future. We had more than 5 different like models, and we tested it, simulated it in Python, which is much more faster in prototyping and testing. There is no external like extra layers of virtual machine. If you're in virtual machine, we don't need to run it, and that's much more simpler. The second step that we had is internal review and plus one external audit on the first, very first version of the code. The reason behind that was to polish the code, because of course the first version can have like simple bugs, some blind spots, etc. That was very helpful. Then of course test coverage. That's like very simple. And then we got 4 audits from different teams, including Certora with formal verification. 2 out of 4 audits are in progress, and they're finishing, I think, within a week or 2 weeks. Depends. And in parallel, we have currently DevNet testing. So basically, that's fully set up environment in Husky. Everybody can integrate with that. Everybody can play with that. If you're interested, you can open our docs, and there's links to our deployment. You can find the whole system, like including slashing, including different delegation models, including vaults, including everything. So basically, the whole system is deployed on Alaska right now. You can check the code. Code is also open. Yeah, something that we prepared before the launch, and it's to be announced soon. And after the launch, like in parallel, we of course will have like monitoring big bounty, which is like standard currently. Nobody should launch without those. So yeah, thank you.
Awesome. Thank you, Algys. This was great. Thank you. Thank you so much. And yeah, just seconding what you just said, no one should ever launch without a live bug bounty program. We have about 10 minutes for questions. We're lucky to get a couple of questions from the chat. So I'll start with those. First one is for you, Anto. You may have seen the question already, but I'll repeat it for everyone else. Only with huge capital like 32 ETH can we contribute in the restaking space, or is it possible with smaller capital?
Okay, so the 32 ETH example was all about running an Ethereum validator. You can restake with $1 if you like. As in, if you hold an LST that is worth $1, probably that wouldn't be enough for the gas, but you can try send it. So we do not have a minimum capital limit. But the 32 ETH is a Ethereum enforced number that you need to run a validator.
Awesome. And we've got another question for you. Is insurance provided by EigenLayer or by external services?
So this is a research paper that Sriram put out. So if you Google StakeSure, you can read it. It is an in-protocol mechanism. So if you are a staker, you will be able to buy insurance against slashing. That is the TLDR, but it's a very detailed paper and it is on our roadmap to implement. The very specifics we wouldn't know. So it takes a lot to go from paper to like code, but I really suggest them reading the paper.
Awesome. I'm sure our audience will do just that. A couple of questions for Algys. It's fascinating hearing you speak about the migratable pattern that you guys came up with. And I had a question around the ability to yank specific versions. So obviously allowing you to migrate and upgrade with the protocol is great, but what happens if there's a known bug in a live version? Do you guys have the ability to stop that version from being used by any user?
No.
Okay.
That's very short answer, but yeah. So basically, we wanted to keep the control over every aspect, including the pause, to owner, because yeah, the owners can stop their vault, but we cannot stop every vault, and like it's a completely thing that we wanted to avoid.
That makes sense. Thank you. Follow-up question for you, Algys. We got a bit of time, so might as well. It's great hearing you talk about the various security initiatives that you undertake at Symbiotic to keep your protocol safe and your user safe. I was wondering if you could potentially extend a little bit on the off-chain security best practices that you guys must be following. So anything related to Web 2 security, I'm sure some of our audience may be thrilled to hear about that.
Yeah, so basically in terms of Web3 security, if you are talking about Symbiotic itself, we are trying to keep our D app as pure as possible, like it's front end and like blockchain. We do have very tiny backend that is basically basically indexing the stuff and from blockchain. But we also have the pure DApp. So basically, the security is like it's very this path is very transparent. We have security to deliver, like to secure our delivery pipeline on front end, but we don't need to have security and like extensive security on the back end because we don't have any sensitive data there. So yeah.
Thank you. That makes a lot of sense. Back to Anto. You've mentioned the upgrade allowing EigenLayer to support any ERC20 token and not just liquid staking tokens or native ETH. Would you be able to walk us through some of the risks involved with that upgrade? We can sense that you're enhancing your attack surface, obviously, by supporting other collateral. But perhaps you can walk us through the design process when it comes to user safety and security that you guys had to, I'm sure, go through for this upgrade.
Yeah. In fact, I just made a PR today to update our risk documentation,
Beautiful. Perfect timing.
Yeah. So I was preparing slides for this and I was like, okay, we need to say something more on the risk FAQ. So you should actually check this. Okay.
I will.
So earlier we determined what assets are good assets can you use for restaking, right? Like it would be LSTs and native ETH. Now you can choose any ERC20, but that comes with certain risks. Earlier, EigenLayer didn't accept LRTs. So those are liquid restaking tokens, right? So what are liquid restaking tokens? If you would like to get a liquid token when you natively restake, that is what an LRT is. So you would go with protocols like EtherFi or Swell. So they run Ethereum validators for you, and then they have their withdrawal credential on an eigenpod. So what that allows them to do is pool capital and give you a liquid token that you can use in DeFi, right? So that's very efficient. But we do not accept LRTs as collateral on EigenLayer. But because we can write smart contracts, someone could wrap an LRT on an ERC20 and then choose to deposit that on EigenLayer, right? So now we are kind of double counting, right? So now the risk has shifted and AVSs who accept these collateral has to determine what are the tokens they are interested in and what are their risk parameters. You could choose to do very risky things, but that is up to the AVS. We, as a protocol, do not make that determination for you. You should, as an AVS, know what are the tokens that are backing your economic security. So we are all doing shared security now. Restaking is how we got started, but now we accept arbitrary ERC20s. So anything of economic value can provide economic security to your AVS.
Awesome. Thanks for the comprehensive answer. We have one more question from YouTube. Anto, could you just repeat the name of the research paper you mentioned?
Yeah, it's Stakesura, Stakesura. I'll just type
Cool.
that in the chat so they can Google it. I'll also post
Stakesura.
Yeah.
Go check it out.
Post the link to the tweet from Sriram. So
awesome.
Yeah.
Thank you. Appreciate it. I believe we are running out of time. I could keep asking these gentlemen a lot more questions, but it'll have to be for another time. Thank you all so much for coming in today, preparing those great slides and walking us through your respective restaking protocols. I'm just wondering if I should pass it up to anyone for some final words. Cool.
Thank you,
Awesome.
everyone.
You're
It was a
retaking
great
that.
panel. Thank you, Mehdi and Anto and Algys. I have a few DSS announcements, just reiterating in case you missed it. This year, we're continuing the tradition of DeFi 101. The DeFi Security Summit includes a lot of cutting-edge material of the latest involvements in security, but DeFi 101 is getting us something back to the basics. So if you're a new person to security or you want to sharpen your skills, that's the event for you. It's cheaper than just attending DSS. If you already have a ticket for the DeFi Security Summit, this is included. It's going to be on November 7th. That's the first day of the conference. We're continuing this tradition from the last 2 years. It was very successful, and I encourage you all to come. And also, in case you've missed that too, the speaking applications have been closed in the last few days, and we are working on reviewing the submissions. So expect to hear about the speakers in DSS in the next following weeks. Thank you, everyone.
Awesome. Thanks all. Hope to see most of you in Thailand at the DeFi Security Summit. Thank you.
Thanks a lot, guys.
Thank you, guys.
Bye.